Hello all, welcome back. As promised, in the last update at LinkedIn that I would be sharing one updated Llama 3.2 quantization video that's specifically meant for fine-tuning Llama 3.2. So our approach is using llama.cpp to convert from a base model to GGUF model. So let's start. So first, what is quantization? So quantization is a technique used in machine learning to reduce the size of the model by uh, representing its weights and activation with lower precision data types, typically reducing the precision from 32 point to 16 point or even 8-bit formats. The process makes the model smaller and more efficient in terms of memory and computational requirements while aiming to maintain acceptable performance. When quantization is applied to large language models like Llama 3.2 or GPT, the goal is to make these models more accessible on resource constant hardware like CPUs and GPUs by reducing the precision of the weights through speeding up inference and reducing memory usage. So what are the types of quantization? So there are four different type of quantization. One is post-training quantization, one is quantization aware training, one is dynamic quantization, one is static quantization. So post-training quantization is applied after the model has already been trained. It converts the model weights from higher precision to lower precision. Quantization aware training, the model is trained with quantization in mind. During training, the model learns to operate with lower precision weights, which helps mitigate the accuracy drops seen in post-training quantization. Dynamic quantization, only the weights are quantized and they are dequantized on the fly during inference. Static quantization quantizes both the weights and the activations of the model. Calibration is done to find the best way to represent activation in low precision. It offers better inference speed than dynamic quantization but requires more careful tuning to preserve model accuracy. So what we would be doing, so steps for quantizing models. So these are the steps that we will be following for our quantization method that we would be applying. Select a pre-trained model. In our case, it would be Llama 3.2. Apply quantization technique to convert it to floating 16 or int 8. For quantization aware training, modify the training process to simulate low precision weights and activation. Evaluate the quantized model and we can deploy. So we'll be doing the deployment in Hugging Face. So that would be it. Now what is GGUF? Because we are converting a base model to GGUF. So GGUF stands for General Graph Universal Format. It's a binary file format designed to store models with quantized weights. Example using int 8 or floating 16 or instead of floating point 32. The format is optimized for running large models on hardware with limited resources such as GPUs or CPUs or smaller GPUs. Purpose: GGUF aims to standardize how quantized models are stored and loaded, ensuring efficiency, memory usage and computation speed. Okay, so let's go through it. We will go into the demo in Colab. I have my Google Colab open, but before that, which model are we taking into consideration? So we are considering this Llama 3.2 1 billion instruct model. So for that you need to have request for access. The access will be granted and the message would come to your mobile, then your email, then you would be able to use the repos. So to select the repo, just you have to copy it and start working on it. Okay, so let's go through it for what we are doing, and this has been done like little bit time ago. So for the quantization, we are considering any LLM, we quantize it into a GGUF format. Okay, so GGUF is a format that allows to run LLMs on CPU, GPU and much more compression. We would be using llama.cpp. So before getting into the llama CPP, like all the cloning, git cloning, but we need to know first about llama CPP. Okay, so let's go through it. So Llama CPP is a lightweight open source implementation designed to run Meta's Llama large language models for Meta AI models efficiently on consumer grade hardware, particularly on CPUs. It is focused on optimizing inference of large language models to work on low-end systems without requiring GPUs. The implementation has gained attention for its portability and performance, making it accessible for a wide range of use cases. So these are the we will just go through the Llama CPP pointers later on. So again we focus. So first of all we will clone this llama.cpp repo. You will see resolving delta has been done and the steps are complete. Then we move to something called ggml CUDA, that is a software that helps you to decide which machines we are using. There is a slight change in the adaptation of how I have used ggml CUDA, because previously we were using QBLAS. QBLAS is no longer being used. So we will get inside the Llama CPP folder that's been created. Then we use the ggml CUDA 1 option and make the entire file and pip install also the requirement.txt file. Okay, so we'll go through the steps. These are the information that's there, like it creates the entire make file that's there. Okay, so after this has been done, we use something called Hugging Face snapshot. So what this snapshot allows us to do is it considers a base model, and we are able to convert that base model into 4-bit quantized format. Okay, so what we are considering right now, as I mentioned, we are into this this 3.2.1 billion instruct model. We have just included it as the model name, but when you start clicking for the first time this model name, this won't work. For that, what you need to do is first of all you will have to log in. Okay, so here you have to pass in your login, notebook login. There would be a token access request. The token needs to be passed from your Hugging Face account. Then you would be able to access this Llama CPP Llama the Llama model that's been considered, because Llama CPP is a gated repo and you need to have an access for that. Okay, so when it is being done, we apply methods. So when we are defining methods, we can pass 4-bit methods. Then we have different type of file names that are that can be passed, and after that what we are doing is that in the base model we are considering the original model. In the quantized path we are putting in the quantized model itself. Now snapshot download, we have the repo ID, model name, we have the local directory and local directory system link. So when we start running this piece of code, it goes through the entire steps, and after that it's written into the original model itself. You see like the details of it. Then after the original model has been created, for the quantization path we are adding this f16.gguf option that's being there. Then after that we are creating a directory named quantized model. Within that we are passing this hf to gguf file that helps in to convert from original model to float 16 format. We have named it as 116.guf, and after that creation you will see like the entire file has been rewritten. There are two types of quantization that's been considered. One is type 0, that is weight into d into q block. D is the block scale. Type 1 is d into q plus m. M is the block minimum. Then we use import os method. We use the quantized path. After that we are considering this floating point format and adding the extension that we have created, that is 116.guf, and we are q type. Take the new model rag with so we want to do some experimentation like talking to the model that's been given. We can do that using this command we are doing. First of all, it loads entire process. After that what I did was I started talking to it, like information being passed. You will see every information is being done. Now here I had some questions, you can do that too. And after that we go to the Hugging Face token. Already this has been done, so you don't have to do it once again. So from Hugging Face hub we are getting this Hugging Face API, which will help us to push the back to Hugging Face repo. We have the Hugging Face folder, create repo and upload file. First of all, we are getting the model path that's been created. So model path is the quantized model path that's been there. This is F116. Then we have the repo name that's being created in that is to be created in Hugging Face, and we create the repo. After that, we are calling in the API. From there, we are pushing our quantized model to Hugging Face. So this is like a repo that's been created. Repo ID is being created, done, and finally we have quantized the model. So after that, when you go to Hugging Face, you will see that your file has been created and being uploaded. So congratulations, you have created the first quantization model of 3.2. So if you want the entire code to be shared, I will share it across probably using my Medium account. It will take some time because I created it today itself. So thank you for watching, and this journey on LLM and also fine tuning will continue. Thank you.